Welcome to lesson 7, the final lesson. Just as a general reminder, I saw some of you guys already posting it in the chat in the Discord, but please show off your Gradio spaces to me. For the people watching this later, that's how I will unlock the certificate of completion for you guys. But B, it gives me a way to show what you guys are doing, and as a result, for you guys to get noticed by other people with the cool stuff you're doing from this course. So today, it being the final lesson, it's going to talk about FastCore and FastAI for a bit. And specifically, I'm going to make sure you guys are familiar enough with both of these libraries, with what's commonly used, some of the practices in them, and give you a brief introduction to some of the ideas that are happening below the surface of FastAI. And then the second part of this lecture is going to be talking about NBDev. And it's not going to be an NBDev tutorial per se. It's going to be discussing NBDev and my personal thoughts on it, how to kind of use it best, and if it's good for your application. Because even I'm finding I'm using it less and less, and I'm doing an experiment right now to see if I truly do enjoy it the same or more than other options. And so far, that has not gone quite where we would have thought, despite all of my anti-notebook propaganda that's been over here. But let me also make sure I have Discord open. Put questions again, either in the chat or in Discord, please. Preferably Discord in the Lesson 7 questions channel. So the notebook here is a little different than the other notebooks because it's not going to be discussing, it's not going to have code notes for the most part. It's going to act more of a cheat sheet. And what I'm going to take today to do is sort of show you where some of this stuff lives and how to find it quickly in the FastAI GitHub, so you can understand sort of how it works more. So first, let's talk about monkey patches. And this has been, if you recall, something I sort of harp on quite a bit when it comes to FastAI. So FastAI and in turn NBDev is taking strong advantage of this practice called monkey patching, which is essentially stating if I have a class defined in a particular Python file and it's used by XYZ, monkey patching says, okay, in a new file, I'm going to add a new function to this class that does not exist with where that class is defined. Right away, you can probably imagine one big issue with that. You've now disjointed the source code. Some of the source code for a class do something exists in this file, but if you don't know about it, it also exists in this other file, which leads to a whole bunch of confusion when you use FastCore and FastAI and you start debugging and learning things. So one such example, though, where I personally find it's good to do this is the FastCore extras package has a whole bunch of different functions defined. So if I go ahead and pull this up here so we can have it on screen as I'm sort of going through it. If we go to FastCore extras, because it is not EXTRAS, there's a whole bunch of interesting functions defined in here. And some of them are defined in this dunder all, some of them are not because they're monkey patches. But generally, they're fairly useful, I've found. What I've seen people do in practice is they will take what's defined in the monkey patch, redefine it outside of the monkey patch for their own stuff, get rid of this magic that breaks typical software flows. And so the useful ones for pathlib, which this is just Python's pathlib library. So this is a Python library designed to work with file systems, right? We saw pathlib being used throughout the course to say, check if a file existed, or open this path object and use it to see what path it is and pass it into, say, predict, right? This whole path class. Now, what FastCore will do is it adds a few other functions to it. Read lines, read JSON, make write, rel path, ls, and delete. These are very, very, very useful functions to have in pathlib. Personally, the way I would write out if you're using it is you have this from FastCore extras import path, and then before that, you also have from pathlib import path. This way, the users can understand, okay, I'm monkey patching some things and maybe put a comment in there. And this is where it originally comes from. Read lines basically lets you open and read a file quickly. It gets rid of like with open ... context manager do things. Read JSON is also very similar. Make write will make any folders that are needed before writing to a file. Rel path gets you the relative path. ls, as we saw earlier, acts as the ls command in Linux, where it will just list all of the directories and the files. And then delete, self-explanatory, deletes. This is the main one that I use most of the monkey patching for. So this is me being lazy. I will do that. If I weren't lazy and I was truly trying to write a package that used this stuff, I would go find this implementation and write it myself quickly. Because if we look at, say, read lines, if I can type right. So if we look at read lines, it is 2 lines of code smushed into one, right? Pathlib read lines does with open, return f read lines, and do whatever. So it's, it opens a file and returns it. That is 2 lines of code that fastai reduces to 1, and also, as a result, is a bit unreadable as well. Read JSON does something very similar, right? So it does this loads, which comes from JSON. So it's JSON loads, and then path.read text, which is not a patch thing. This is just standard lib, and do this thing. So a lot of these that modify path are really just strong convenience functions that wrap around, if you're not careful with spacing, 1 to 2 lines of code. If you're careful with spacing, 3 or 4. And so it does not take a lot to just simply go through, copy paste the code, and be on your way. That is how I would personally approach patches like this. There's, we look at patch. So we have all of the pathlib patches, and that's actually all that is in here. I was trying to remember if that was. There's other functions like open file in here. Untar data happens to exist in here as well. So it's got some useful functions for you in here. Personally, I would not rely on fastcore a lot because, again, it is the weird magic class that fastai is built upon. So in turn, by using it, you are bringing in the magic. But let's talk about some more of the magic. Another idea you will see in fastai and function specifically is something called store attra. This exists in basics, and basics just has a lot of basic fundamental parts of fastcore. And what store attra basically does is it reads the function signature and says, okay, I have something called B and I have something called C. I'm going to store all of these in the class as attributes. Now, for convenience, that's great. For readability, not so much. Because if you're someone who doesn't understand what store attra does and you see nothing being passed in, you sit there and go, what is happening here? When in reality, B and C are being stored to self.b and self.c. So in this case, use it in the sense of understanding what it does with fastai, but I would not say use it because it's unclear magic that I don't personally enjoy because it brings in a bunch of sneaky things. Now, next on the sort of foundational parts of fastcore, we have the L class, which this is one where I will say is useful and probably could be used in a lot of different places. And basically, L lets us create a map that has a whole bunch of operations embedded into it. Things that normally we would need to wrap around and check for. So in this case, it replaces 1 line of code as well. Like if we look at foundation, look at the L class and everything that is patched in it. Well, actually, not even patched. Nice. It's all just defined right here. So you can see like it just has like enumerate, which calls enumerate on itself. We have a map dictionary, which takes a function and maps in and creates a dictionary of that map. It's filter, which creates a filter of bits like that, splitting a list into a variety of different ways, multiplying, addition, other functionalities that are useful. that are not just in the standard Python list class. So from that perspective, this is a very nice powerhouse to use. It is a bit more magic in the sense of it's just called an L, and that's it. And it is just because it is used so much that Jeremy's naming convention keeps it as one letter. I would call this magic list or list. Something that makes it obvious, sort of, that this is a list that does a lot of different things. Or a, oh, what's another word that I want? Operational list. Something like this. Functional list. That's probably the best case scenario for this thing. But it lets you do useful things. Like I can map a function to every single item in here instead of doing the map that I showed you guys earlier in another class. I can also use it to count the number of times that something shows up in a list. So 3 showed up twice, it returned us 2. And you can also perform basic arithmetic off of it. And so with this sort of functionality, it lets you use a lot of functions very quickly through just the list. Again, you can do all of this without the list per se and not bring in the weirdness of it. But this is one where I'd be fairly okay in saying this one's not too bad. Manny brought up a very good point. Store attra has a lot of similarities to the data class. Yes, actually, it's practically exactly like a data class, except as a function. So it turns every class into a data class by behavior. What I mean by this is data classes are a way for you to essentially create a class that will automatically create its init for you based on what you have. So here I say, I want name to be a string, unit price to be a float, and quality on hand to be an int with a default to 0. I use the data class decorator, and it will create an init function for us here that stores everything. So rather than add data class, you still have to define init, but store attra handles this part. But again, it's a bit off the beaten path in what that does, so use at your discretion. A few that I actually do enjoy are the attra dictionary, dict to object, and object to dict classes. I actually brought in what was essentially the attribute dictionary into the Hugging Face Hub because it's super useful when you're trying to write repr-based classes. And what I mean by this is in the Hugging Face Hub, there is something called the model search arguments and dataset search arguments that essentially let you have a object and a dictionary at once that you can check all these different attributes and properties for to see what models are hosted on the Hugging Face Hub. And so it's a very exploratory fashion of getting everything, but also works for people who aren't using notebooks. And it was entirely based upon the attra dictionary class. And so you can see here, like the attra dictionary lets you do object basically here. So it lets us do .a to get the attribute and index into it with a as a key to get the attribute. So from that extent, it's useful. And actually, I do like this class quite a lot. The other 2 useful functions are dictionary to object and object to dictionary, which, as you can imagine, basically convert a dictionary into an attribute dictionary class and the reverse. So those are very useful if, say, you're not using attradict from the start and you don't want to do a huge definition and you just want to create an object with it. This set, I actually do personally enjoy quite a lot. The next part we're going to talk about is documents. And documents is specific to NBDev. And so someone brought up a very good question. Why is magic so evil in regular Python programming? The reason why magic is evil is code should work how a user expects. And if code breaks, a user is expected that they will be able to roughly follow what's happening through the stack trace enough to maybe help with their debugging experience. And if it doesn't, then they open a GitHub issue. If you introduce behaviors that do not follow the systematic code of how Python is written, then you're introducing friction into this debugging experience. And on top of that, sort of how code is written and expected to work. A very important example of this, which we'll get to in a bit, is things like fastai's transforms. It is probably one of the worst magic fastai does, is its transform API. Because this whole type dispatch system that I'll mention later, Python doesn't originally have multi-dispatch. Essentially means, based on this input, I'm going to run this version of a function. It did not exist in Python ever. It existed in other languages instead. And then people from other languages that enjoyed it, such as Jeremy and other folks as well, brought it in. Someone eventually took Jeremy's type dispatch and made it better. And now we use that type dispatch here. However, type dispatch is non-Pythonic. Python programmers expect Python to work like Python. It has its own problems. It has its own special quirks. And it runs like Python. It is an object-oriented language, not a static language or scripted language. That's what I want. So when you break this sort of barrier of script, you alienate every user of your library because they're expecting Python to work in different ways now. And this is why it's bad. It's bad it's not bad in the sense of this library is terrible. It's bad in the sense of its usability for the general audience, because it's not supposed to work like that. The general audience has grown with and learned how Python works, how to get around it, and how to make these get-arounds readable. Instead of monkey patching, you use class inheritance. Instead of, say, actually, that's a very, very real example. You don't do monkey patching in Python. It is the worst cardinal sin of all, due to the fact that you expect if I import this class, it should operate like the class normally should. With monkey patching, all of a sudden it doesn't. I import pathlib because the examples say fastcore brings it in. We're not even going to talk about import all. Import all, I think, is even worse than that, because if you import all and say brings in pathlib, you assume fastai brought in pathlib, because if you look at pathlib, it says pathlib.path. But magically now it has a whole bunch of extra functions, and I have no idea where they came from. So this sort of magic introduces friction into your programming environment, where if you're not in the know to what's going on, things break, things behave weirdly, and you don't understand what the heck code is supposed to do. This is why magic is generally so. Many brought up a good link on there on the open close principle, which is very important, especially in Python, because another part of Python that's a bit quirky is every other class in existence, and or at least object-oriented framework. This is a tangent for a bit, but I'm hoping you guys will enjoy this. So Python doesn't have a concept of private variables, okay? So everything that's there is there, and the user can get access to it immediately. You can start something with a double underscore or a single underscore, and it is all there if you create the object. In Java and other object-oriented programming languages, the user can't have access to that. And so one thing that's also very common, especially when you see in fastai, is this use of underscore starting functions. And a lot of classes do. A lot of libraries do this. Fastai uses it a lot. And it wasn't actually until I was talking with Sylvain when I was working at Hugging Face that he sort of told me, you don't do that. It's not worth having the double underscore. If you're going to write a function, you're going to assume it's exposed to the user. And if not, you're going to explicitly warn that it should not be. Because everything is public in Python, in the sense of a user and a class can all access the exact same functions of something. A function is not strictly internal to this class alone, and nothing else can touch it. Like it's a black box, and the black box runs a function. Python doesn't work that way. And so again, if you introduce this magic, it makes it more complex. And where this exponentially gets worse is Python is one of the most commonly used programming languages in the world because it is so simple to understand and fast to work with. Increase friction, increase the amount of people that have trouble working with it, and thus you decrease usage of it. It is no longer beginner friendly because you're introducing these complex ideas that break the foundations of it. Alan made a good point of Python is very slow to adopt ideas from other languages, and Python users tend not to have exposure to a lot of other languages, and so they don't know other common programming paradigms. Exactly. The audience of Python is generally, it's kind of like you have the very beginners of learning programming. You have people who move on from here and go into something like Java or C++, Java if you hate yourself, C++ if you mildly enjoy yourself. And then you have the experts that have learned after that and come back to Python. And so, you have the experts over here that are adding all of this functionality, but then alienating everyone over here because they're learning the framework to do this before they move on to something else and learn those internals. And then this is something entirely different. So generally, that's why the rule of Python is reduce as much magic as possible, because these aren't going to be, senior software engineers looking at this. They're going to be juniors, because it's meant to be for juniors in the sense of readability. And yes, you can use the cheap shot of saying this library uses magic. I would not recommend using it for beginners. But what you've then also done is reduce the amount of users that use your library to, like, say 100,000 to 1,000. You're not going to get that much adoptability. And, the bugs that people are going to have are things people are going to get frustrated over more than, hey, I think this might be different. A very plain example of this is when I was using fastai regularly, I'm unsurprisingly what people would call a power user. So I would go until something broke, and then I'd see what broke and figure out why, and then, put a PR in to fix it or raise a notice or something and say, hey, I want to do this, and I did this thing. Debugging fastai is hell because of many principles that it uses. And because of that, the code base is one of the hardest code bases to navigate in the world. And so to, say, put in a fix for something that I think is going on could take me 1 to 2 weeks. A library that doesn't use any magic and is very plain and explicit in what the code is doing, my library Accelerate, at work, when users run into bugs, I'd say it's about a quarter of the time they go, here's the bug, here's why. Want me to put a PR? If not more. The code is very approachable to people who don't even know distributed programming. And it's because, we don't abuse principles like dry, don't repeat yourself. I'll talk more about this in the API course, but you can look up dry, and fastai basically follows this biblically. Along with everything else fastai and fastcore does, makes the framework very hard to work with. And it's also why I personally call fastcore, I think Hamill called it best. Fastcore is a Python dialect, but it is not Python. So anytime you code in fastai, it is not Python anymore. It is fastcore or fastpy. And so it's a very frictionful library, which is why I keep bringing up this point of do things without fastai, because this friction will exist. You'll have to deal with these bugs and these special behaviors that users aren't going to expect. So I will happily keep renting on this, but let's talk some more about the interesting parts of fastcore, and then I'll take another question break in like 5 to 10 minutes. So it has another section called test, and it essentially operates as asserts in notebooks. So it has a lot of them that are very similar to PyTest, like test equal, test not equal, test close, is shuffled, and so forth. And NBDev and fastai use this sort of as their testing. It's okay. I prefer unit test. It's designed to work in notebooks, and that's okay. But you're reinventing the wheel, and things don't, again, operate how you would expect when you start mixing it in with other things. So be familiar that you'll see stuff like this that does tests, but use something like PyTest instead, or unit test that write explicit assert statements. Now let's talk about the type dispatch system and the transforms. So this is going to be one of those parts of fastai that is going to be really frictionful when you're reading code, because every type dispatch is not always defined right after each other. And this is especially used in the transforms API. but essentially how type dispatch operates. Type dispatch, also known as multi-dispatch, says, okay, I'm going to write the same function a few times, right? So I'm going to have my transform, and the behavior of my transform should change based on what the input is. This is very common in strictly typed programming languages to incorporate different behaviors based on what's passed in. fastai is not a strictly typed language. What this means is that if you say have value int and I pass in a string, it won't throw me an error. It'll just use that string. Type dispatch makes it a bit more strictly typed in the sense of I pass in an int, it's going to print out this. If I pass in a string, it's going to do this. And if I pass in a Boolean, it's going to do this function. But because, again, Python isn't built for type dispatch, it leads to a whole bunch of issues in the framework. And what I mean by this is when you do my transform question mark, it'll bring up the first version of this that's defined, not all the versions. And on top of this, the doc strings won't align A to B to C. And so it's very frictionful when you're trying to debug because you're saying, oh, my transform, but I don't know which version of my transform is actually happening. So I'm doing an experiment right now where I'm trying to rewrite most of the fastai library. The next part is getting rid of type dispatch to do a dispatch system for the transforms. And I'm going to attempt to do it without type dispatch entirely and make it still workable, if not using type dispatch in a way that's workable. But the way fastai does it right now is not, and I disagree with it entirely. So if we call these things, you can see it pass in an integer, pass in an int, string, bool. And then this scales up, as we get into the, again, type dispatch system, and it is able to take in, say, a PIL image, and the resize transform works on PIL images, it works on segmentation maps, it works on, say, points, like heat maps or key points. It will run its very specific resize transform for those classes of inputs behind the scenes. And because that's so different from everything else and a very foundational part of the framework, it becomes very confusing and overwhelming for new users. Why did fastcore need to create its own test system? Because it was built with NVDev and it needed to work in notebooks. And PyTest is something Jeremy did not like, nor unit test, despite the fact that they are industry standards. So he created his own testing framework that allows it to be done iteratively. Personally, I prefer, if you're going to do that, just put an assert statement instead of using a special with that. Instead of test equal, use assert x equals y. Or just put that in a unit test somewhere or a PyTest test. You're noticing we're getting more and more away from using a notebook. So next we're going to talk about the pipeline, which we already talked about the pipeline, but is here quickly as a reference. And the pipeline class basically takes a bunch of transforms and will iteratively set them up and call them based on what its input is, based on the type dispatch system. We're familiar with that. So now let's talk about the ones in fastai specifically, because not every magic utility function exists in fastcore, despite the fact that it is called core. fastai itself contains actually a lot of useful functions that can be used in a lot of different ways. So the first one is defaults. Now, this is one of those non-helpful ones. Defaults is a namespace class that contains a whole bunch of information about defaults that exist in the framework. But defaults is modified everywhere. So it's inherently monkey patched because we're adding attributes on import. So things change even though you define it in one place. And what happens with that is I can't do like default question mark and see the source, right? If you were to write a namespace class, you would say do, like, I'm just going to pull up a scratch pad here quickly. So like if I was to write a namespace, I would say class A, self, and I'd say like self.a equals 1, self.b equals 2, self.c equals 3. And it's now essentially a namespace class. Defaults instead says defaults equals object, defaults dot a equals, and defaults is defined in one file, a is defined in another file. Or really, I guess it'd be setatra defaults a2, maybe. What's funny is that doesn't even work properly like that. fastai does its own magic thing that lets you do that, which again breaks Python. Instead, you would define it as a class. And so as a result, if I say have class a equals 2, and I do a.a, normally I can put a question mark there. If Colab isn't going to break on me, we're going to try and have it work a bit better. I know you all love my iterative debugging stuff. It might actually not. I'm accidentally using the wrong compute type. No, Colab's been giving me issues the last few times. But basically, you can define it like this, do a.a, and it'll give you the source code for it to a certain extent. And a hint at where it's defined. Defaults doesn't. And so you have to go squirming around and do basically a control F through the framework source code to figure out where something is defined. And you can never figure out what all of the attributes are unless you do like a inspection of like a converting it to a dictionary or see all of its attributes. Do something like, not iter, I guess just wrapping a dictionary around it. I can't remember the name off the top of my head. So it's extremely hard to follow. It's useful to know about because if something exists in fastai that has a default behavior, it is because it is defined somewhere in this namespace. And then if you want to go see why, you then have to go dig for it. But you at least know where to start. That is what I want to help you guys with. Rowan asked a good question of, can't we use if-else statements in a single function instead of type dispatch? Yes, you can. And that is the Python way to do it. That just sadly isn't something Jeremy likes with his brain. But yes, that would be the Python version of writing type dispatch the proper way. Now, a few useful functions in here that are good to use. fastai in TorchCore has something called the apply function, which, similar to l.apply, will take some function and a list and apply it to that list. This is super useful, and it's very explicit and apparent in what's happening. You're applying some function to an item. Concat is also useful. It lets you concatenate tensors, arrays, lists, or tuples. This is a very handy utility that works as intended. It's going to concatenate everything together into a particular dimension with whatever you pass it. And then find batch size is something that I think we even brought in, Sylvan brought in to accelerate as a utility. It's very nice because you just pass in a tensor and it gives you the batch size. This has tons of useful bits for writing Python code for PyTorch. If you're writing custom PyTorch code that needs to depend on the batch size, you can find it very quickly no matter what is passed in, instead of trying to search through, say, a dictionary that is passed in as an input. It will just tell you it and find it. Another special one is TorchCore's NN module. And really, it's just module. And it removes this requirement of super init that basically every single PyTorch class has, and saves one line of code, while also then making it more confusing. Because someone from PyTorch that sees module might think it's NN module, just imported from it, and now it is not behaving like you expect. Please use NN module instead of module. I'm big. And sort of as I mentioned here, there are so many other functions and resources fastai and fastcore use. Most of what I study from are located in extras in TorchCore. And something that could be a good exercise is to take what's written in TorchCore or extras, if you wanted to get your Python a bit better, is take that and then write a super small library that just has those functions rewritten in non-magical ways. So undoing all of the monkey patching, or rewriting, say, a foundational function that's in there in something that makes sense, similar to what we did with the random resize crop transform and how we took out all the magic of that function's definition and made it apparent. Now, the reason I did that is for you is because That's a highly complicated function, but there are others that are not. So this as a whole is fastai and fastcore in terms of functions that are useful, library practices, and things to basically watch out for. Are there any questions here before we move on to notebook dev? And I'll let questions brew. We'll take a 5-minute break and come back here at the... All right, welcome back, everyone. That sounded weird, and I know why now. Something else that came up in the Discord chat is this idea of like, it sounds like Python is, so far behind on everything. The reality is not really. Like the latest versions of things like Python 3.12, Python 3.11 introduce a lot of neat and interesting ideas. And so then the question is, okay, well, why doesn't everyone just use that? And it's because a lot of systems are not built to be updated with their base library every 2 years, every year. They're designed to be built in the language it was built in. And depending on how big that gap is, it's harder to make that happen. And so you have two choices. You either support the older versions and sit there, and when the oldest version hits what is called its sunset date, then you update to the next version, or you stay on mostly the bleeding edge and have all of the cool toys. The better way to write software is the former, because you'll be able to have a lot more users. The bugs that are there are usually already known. And while development of the new toys is slower, you're more stable. For instance, Accelerate only dropped support for Python 3.6 when its end of life happened. And, and then when Python 3.7 hits its sunset, then we'll do that. We support up to, whatever the latest version is. We have tests for it, but we don't actively integrate new features that are strictly from that version unless there's exceedingly good reason to do so. And so if a feature does exist in there, because Python is Python, you can rewrite what it does with not too much trouble and rewrite it in a way that impacts a lot of users using a particular version of the code. A very specific example of this is, and this is going to be very high level, and some of you might only be the ones that get this, but when I was coding in NBDev for a bit, it was using this, well, generally you can do something called parsing Python code using something called an abstract syntax tree, which basically tokenizes the code and maps it out in a way for you to explore interactive and modify on the fly. Python 3.11 introduced a way to unparse these parsed strings in this language, right? So I could take in a chunk of Python text and then unparse it and get that chunk of text back out. This is super handy when you want to modify source code or clean it up, such as with NBDev. But it existed in Python 3.10, and the rest of the world uses Python 3.6 or Python 3.7. So there's a library now called ast unparsed that quite literally takes the Python 3.10 implementation, or 3.9, whichever one it was, of unparse, and just uses it as a library for people to use. Because, yes, I can go use Python 3.9, Python 3.10, but I alienate a huge majority of my audience if I do that. So this is one example of how you can get around using the new toys if you want to. You just use it yourself. You could copy paste the code if you wanted to, practically. And then just state that it came from Python and what it actually is. So this is another one of those ideas of making your code sustainable for the long term as well. And so it's, okay, what is the minimum Python version I want to support versus what do the rest of my users use? Like, for instance, even after Python 3.6 hit its end of life, Google Colab still was using Python 3.6 for a very long time. And then 3.7 still, and only now recently it's using 3.8, I think, by default, not 3.9. So it took a long time for that to work. And so anyone that wanted to do anything with programming in Jupyter Notebooks, you had to make sure it worked with Python 3.6 because everyone wanted to use Google Colab, which is a very big limit for fastai in order for it to want to be able to use its magic. So just a general rant again, talking about sort of software practices. And I just closed the wrong tab. That's fine. And again, keep questions coming. This is excellent questions. I love sort of what we're talking about here. Now let's talk about notebook dev. The library, I have a very love-hate relationship with it. So as I've sort of mentioned multiple times throughout the course, not everything, not every software library can nor should be built on NBDev. It is good for small libraries, but when it comes to big libraries, you lose efficiency at the cost of clarity. So it's a double negative. However, it was built by a data scientist for data scientists who use Jupyter Notebooks. So in that regard, it does make sense as to why it exists. You know, it follows this idea of WYSIWYG. What you see is what you get. But there's a whole slew of issues that come into place when you do this, when you have to rely on a Jupyter Notebook, which has options like execution control. So I can run cells out of order. There is nothing stopping me from doing that. And I especially do that when I'm sitting there debugging. If you introduce order into that, you're adding friction into the general way that people use notebooks. They're meant to be interactive and mutable. What I mean by this is NBDev builds on this idea of source code and documentation all exist in a single Jupyter notebook, right? So if we go look at the fastai source code, for instance, there is a notebooks folder, and there is a notebook for every single Python file that exists in the library. So I can go over to TorchCore, and if we open this up, we can see there's some weird comments here. Source code is being defined, and some documentation is being defined, and some tests, right? But notebooks are also stateful. So what this means is, say, I'm going through, I'm running all this code, and then I realize, oh, this function has a problem. Okay, well, I'm going to modify it down here, right? I'm going to define it somewhere down here with my custom implementation and be on my way. Well, I can run this, but if I still run subplots, it will point to the old implementation of it. It won't point to the new one. And so states in notebooks is very anti-programming in this sense of exploratory programming that NBDev advertises. So it's good, but it doesn't, everything has to be done exactly in this order. And you have to assume that the previous cell or the current cell might rely on the previous cell. And so if, say, the notebook breaks, I have to completely restart the notebook from scratch. This is compared to, say, working in an IDE like VS Code, where I have a separate test file. Oh, something breaks. Okay, I can just rerun that one very specific test, modify the source code, and I'm done. There's no state. The state is made when I run the tests, and that's it. And so that's sort of one, it's very funny that talking about states and has states here, but that's sort of one example of why this is bad for big, large-scale libraries. For small libraries, which is what it's advertised for making brilliant small libraries, yes, it's great. I mean, again, I built this entire course off of this. One thing I'll show in streams is talking about fastai or NBDev extensions, which is an extension library for NBDev that I built this course on. So for small libraries, it works great. But as you scale more, GitHub doesn't have good interfaces to work with Jupyter Notebooks. Jupyter Notebooks are also just the bane of Python programmers' existence anyways, because if I have to change code in more than one place to do one thing, that is bad. And so it's a bit too dry. Dry being don't repeat yourself. So it doesn't scale well in my opinion. I'm going to be running a test with this to see if that truly is true or not by basically rebuilding the core of fastai using NBDev in the way I believe it should be used in VS Code with Copilot, not in Jupyter Lab or Jupyter Notebook, because that is not what I code in. I code in VS Code, and I code with Copilot because it is phenomenal. And I also do it for very quick feedback. So, to that extent, running with fastai is basically going to be built on this idea. And kind of the API design course as well to see if this works. If it doesn't, I'm just not going to teach NBDev. Because if it doesn't work for me in the real world, I'm sure not going to teach it to you guys. So bear that in mind. But let's talk about how it all works. Now, I talked a lot about bad, but I also talked about some good, so let's keep going with the good. So the general premise with NBDev is they rely on this thing called directives. And directives is this interesting comment that you see like here, somewhere there was a hide, I know. And NBDev will essentially read these different flags and do things with them. So in a single notebook, I define a default exp, which says by default, export to a file. So if we go to this Torch Core folder, or Torch Core notebook, you'll see default exp Torch Core. So it's going to export to torchcore.py. And what is it exporting? Everything that has export or exports. So everything that has this comment, pipe, and export will get thrown into a Python file. So if we look at Torch Core again, that's saying these imports are going to go into torchcore.py. There's other few ones like hide, which makes it so that a certain cell isn't shown in the documentation, because when the notebook, source code, and tests all exist, or source code, test, and documentation all exist in the Jupyter Notebook, the Jupyter Notebook is the documentation. That is part of that. So if you don't want things to show up in there, like tests, you generally wrap it in hide. And then the last one is echo. This echo false, it's a little different from NBDev version 1. And it's actually Quarto specific, what NBDev is built on for a documentation framework. But that just hides the output of the cell. So, a way to do this is, so say, when I write a cell that has default exp, my module name, I don't 100% know why that's not on the same line. And say we write this addition function, how this will render in the documentation is it'll look like this. So we have add two numbers together, the function definition, or the function name, and the function definition, then it'll show up on the table of contents over here. I just need to quickly check something, because I can't remember if I did something or not. So, sorry. But basically, this is how fastai automatically renders its documentation based on these Jupyter notebooks and sort of what that looks like. Now, there are a lot of things I don't necessarily like about the NBDev practicing paradigms, as obviously I have said a lot. One of those is this idea of, one-line doc strings. But I'll bring this up over here because there's nothing proprietary over here. So remember how we had code used and then we had these two definitions? This is what it looked like in the notebook. So we have export here, which says I'm going to export addition. And then we have export S and subtraction. So when I rendered the documentation, addition is rendered. It doesn't show the source code. The source code for subtraction is shown, and then the documentation for it. And so this is sort of how NBDev uses this sort of export and ideology of these directives to create code and do things on export. NBDev extensions does this. That's how the code notes, what creates the code and explanation, utilizes. Since mine is documentation specific, there are ways for you to do it in Quarto. For this, though, I find it easier to just do it in NBDev, because if I'm going to use it, it's going to be used in notebooks. I'm not going to use it in Markdown. So that's sort of the general idea of NBDev. And so now let's talk about a few bad habits. And again, these are things that I'm going to talk about much more in the API design course, as well as, in running, I'm going to talk about it. A few of them are using monkey patching to save on lines of code. Those monkey patches where we had path.ls that replaced one line. I would rather you create a new pathlib class that inherits pathlib or path and does the functionality and extends it the proper Python way that is expected. Another one with nbdev libraries that you will see, and I am yet to see too many frameworks that do it right using nbdev, is minimizing in lines of code in general. It's very lazy. It just is. You're optimizing for keystrokes instead of readability. And then on top of that, not really utilizing the docstring fully. What I mean by this is not just beyond one line doc strings that you will see fastai always use. One line doc strings and the fact that those documents I described earlier can't be rendered in an IDE like VS Code. It's not going to show this input documentation because it's expected to exist in the docstring. And so because of that, you're adding more friction by saying if you want to use nbdev, you have to use nbdev if you're using an nbdev library. Because otherwise, debugging, you're not going to know what you're going to do or what is going on. And if you do question mark, it's not going to show those comments when you pull up the source code. So there are ways to use nbdev well. I believe there is a way to use nbdev the best that I need to still play with. But, as I sort of started with this lecture, I don't advocate using Jupyter Notebook for everything. I was obsessed with it for a while, but I've been working at Hugging Face for a year and 3 months. The amount of times I have touched a notebook is smaller and smaller and smaller. And the amount of times I get frustrated at a notebook where it expands the amount of time I need to do things is larger and larger and larger versus an IDE where everything is streamlined and smooth. And so I don't really know if I advocate nbdev as much anymore, personally, in that sense. I'll put it this way. Quarto and nbdev are good for blogs and good for writing very small libraries that have very specific things. Don't really recommend it for large-scale frameworks, though. But I wanted to show it to you guys here because fastai is built on this. This is a class on fastai and how to use it well. And so that includes understanding how to read how it is written because you need a class on that, for better or worse. So that is basically the lecture for today. If there are any more questions, please put them in the chat. For the next few weeks, at least 2, I'm going to stream on nbdev extensions. Might be recorded, might not. Got to think about it because they're not really lectures per se. They're just showing you guys what it is. But basically, that is the end, officially, of Walk with fastai Revisited. We've been on this awesome 7-week journey, taking you guys from understanding a little bit of fastai and coming with an expectation of how fastai could be used, and graduating with an understanding of why you shouldn't use fastai the way it's advertised, the risks involved with using it, and giving you a step in the right direction of how to start removing fastai coding and fastai when you want to have more stable and secure code. From here, if you've made it this far, then you will obviously get a certificate showcasing that you did in fact complete the course. Again, the other requirement for this, for those of you who are not watching live, is to post in the Show Your Space chat your homework assignment of a published space. Deploying fastai to some extent. It does not have to be without fastai. It can be with. But otherwise, I am pretty comfortable with letting you guys loose in the world of fastai and hopefully starting to change how people view this framework. Now, I've talked about a few times. After this course, ideally, I'm going to put April, May as a timestamp. That could go great. That could go wrong. I'm going to do it how I can, when I can. There will be another course talking about basically How do you write a framework? How do you write fastai? How do you write accelerate? How do you write transformers? And the decisions that are made in that from a Python perspective and a PyTorch perspective, not from a software engineering perspective. And then after that, we'll be running with fastai, finally, the course that has been planned for literally 3 years, taking everything those first two courses built upon, and then really digging into the fastai code heavily for utilizing the framework. So how do we write a callback? What does type dispatch actually do in its source code? That one, hopefully I can get out before the new year. We'll see. It's going to be after the Python course comes out, but that is Walk with fastai. So thank you all so much for giving me your time and supporting me as we've been going through these last 7 weeks. Every single one of you is now more prepared than majority of the people in this community. And I'm very comfortable with calling you guys advanced users of fastai now. So again, thank you all so much. Super appreciate it. This has been a blast. I'll post in the Discord when we will have those live streams. But otherwise, see you all on the forums or in the next course. Thank you.